Not. So you can move up though. This isn't a 5-minute lesson because there's no way I can do this in 5 minutes. But we're going to get into graphing things in the polar system. Now, this is the third section of polar, so by now you've already started plotting points. I'm going to pause this real quick. All right, I was just catching people up on what polars are. It's a system that changes the way that points are mapped. We go away R units and we rotate counterclockwise theta degrees. Okay? That is counterclockwise, yes, this way. So, what do you think the graph R equals 6 looks like? What are all of the points that are 6 units away from the origin where the angle is unlimited? It's a circle with radius 6. Here you go. There's R equals 4, but now I got R equals 6. It's the red one. Okay? Now, one thing that's weird about polars is R equals -6 does exist, and it's the exact same circle as R equals 6. So you have a lot of redundant points in the polar system. It's not 1-to-1. Here's a way to think about it. The point 4, 0 degrees is the same as -4, 180 degrees. It gets kind of wild, okay? And that little concept is why some of these graphs end up looking a little bit funkier than we would have expected. I just found out today, Desmos will not let you graph that, which is weird. But what do you think theta equals -π/3 looks like? Well, what's -π/3 in degrees? -60. That is the line. Theta is -π/3. It's a straight line. It's every point that's that angle away from the origin. Well, here's where it starts getting fun. R equals 3 cosine of 2 theta. That gives you this rose curve. And I've tried to create this chart for the first 1, 2, 3, 4, 5, 6 points. But unfortunately, they map those points on the XY because it won't let me put theta in. So you have to ignore these blue points right here. And we need to look at these points in terms of theta and R, okay? So this point is 3 for R and 0 for theta. This point is 1.5, π/6. This point is 0, π/4. -1.5, π/3. And then -3, π/2. Let's look at where these 6 points lie on this graph. 3, 0 is right here. 3 units, 0 degrees. 1.5, π/6. Well, here's 1.5 right here. And π/6 is 30 degrees. And look, you can see it. It's right. Oh, sorry. This is 1.5. Bang. Right there. That's 1.5, π/6. 0 for R, π/4. Notice, if our angle is π/4, we are back at our origin, 0 degrees. Sorry, 0 R. How do we get that? Well, 2 times π/2. 2 times π/4 is π/2. Cosine of π/2 is 0. 3 times 0 is 0. All right, here's where it gets weird. -1.5, and then π/3. So we go here, and then we got to rotate π/3, and now that point is right there. So actually, if you look at how this curve is traced out, it actually starts here, goes from here to here. That's the first 45 degrees right there. Then here's the next 45 degrees. So that's after 90, it's gone there. After 180, I think it's done that. No. I lied. I would have to keep looking. It has to make a different path. I think it goes here and then there, right?
Yeah.
And then now we're at 270. And then that is the final 90 degrees. So now let's look at another one. Let's look at 2 plus 3 sine of 2 theta. Okay. Come on. Clear. Back. 2 plus 3 sine 2 theta. This one's going to be complicated. R equals 2 plus 3 sine 2 theta. Notice that one gets super funky. So you can see these curves look a lot like your artwork. You guys were rotating your artwork. Okay? And I hope this interests you enough to play around with some of these graphs in this lesson. That's this video. I hope it helps.